Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about relative velocity for NEET and JEE. First we will do a quick review about theory, then we will go to the problems. Okay, what is relative velocity? The relative velocity means the velocity at which a body is appear to a person, or we can say that relative to other object. What about the velocity of an object? That means you take an example. Okay, in this road there is a bus is to be there. This bus is moving in this direction and a person is standing here, and there is a car is moving in the same direction and a person is walking in this direction. Okay, so you look at here. A person is standing here, he look this bus, he will feel that this bus is moving some velocity. For this person, a person in the car, he will feel this bus is moving with some other velocity, and this person is moving in the opposite direction, he will feel that other velocity. That means from the person to person, an object velocity is to be different. So we will take the ground is to be the reference, and the ground velocity we have taken as 0. So if a car is moving on a road with a velocity 40 km per hour, okay, a car is moving on a ground with a velocity of 40 km per hour. That means with respect to this ground, this car velocity is 40 km per hour. With that velocity, we will feel this car. Okay, so we can say that the car velocity is equal to velocity of the car with respect to ground. Velocity of the car with respect to ground. Okay, so this is the velocity this car. That means what is the velocity of the car with respect to ground? Velocity of the car with respect to ground is velocity of the car minus velocity of the ground. What about the velocity of the ground? That is 0. So velocity of the car itself. So what about the velocity of the car? That is 40 km per hour. Okay. This is the basics. Based on this, we will discuss about the different cases. Okay. First we will discuss you look at here, a car moving in this direction with a velocity Va. A person is standing here. For this person, with what velocity Va is appear? That is the relative velocity of A with respect to P. So, relative velocity of A with respect to P is relative velocity of A with respect to P is velocity of the A minus velocity of the person. Here this person is at rest, so its velocity is 0. Okay, so for this person, this car is moving with its velocity like that, he will feel. And the person in the car looks this person, this standing person. With what velocity the standing person appear for this car? Okay, so we will see that. That is a relative velocity of person with respect to car. Okay, is how much? The velocity of the person with respect to a car, that is velocity of the person minus velocity of the car, that is Va. Okay, so we will get this velocity is 0 minus Va. That means, what is the meaning? For a person in the car, he will feel that this person is moving in the opposite direction. That's why this negative sign, moving in the opposite direction with the equal velocity of the car. Okay, this is why you may feel that when you are going in a train, you look outside the train through the window, you feel that the trees are moving. When the train is rushed, you will feel that the trees are rushed. When the train moving, you will feel that the trees are moving in the opposite direction with some velocity. This is the reason for that. Okay, clear? Then next we will see about the next case. Another person is in a car B. Okay, this is moving with the velocity V. Okay, along the same direction. Now a person in the A looks B. With what velocity this B appear for A person? So that is the relative velocity of B with respect to A. Relative velocity of B with respect to A. That is what we can, how we can write it like this. Relative velocity of B with respect to A is VB minus B. Okay, with this velocity, a person in the A will feel that the B is going away. Person in the A feel that with this velocity, A is moving away from him. B is moving away from him. For A, B is to be moving away from him, like that will feel. Okay, with this velocity. Okay, so now you see that the velocity is decreases, two persons are moving. This is why you feel that when you are going in a bus in this direction, another bus is coming in the same direction with the same velocity. If you look at this bus, what you will feel? You will feel that these two buses are at rest. So this reason, if they have same velocity in the same direction, what about the relative velocity is 0. So you will feel that these two buses are at rest. Okay, this is about this case. Now we will see the next case. A person in the B looks A. With what velocity A will appear for this person? That is the relative velocity of A with respect to B. So now we will see the relative velocity of A with respect to B. Velocity of A with respect to B, we will write like this. Relative velocity of A with respect to B. That is VA minus VB. If they are going in the same direction. If these two are moving in the opposite direction, that means you look at like this. If B moves like this, the velocity. With what velocity A will appear for this person? Okay, so that is the relative velocity of A with respect to B. So relative velocity of A with respect to B is VA plus VB. That means when the two bodies are moving in the opposite direction, the relative velocity increases. That's why you may see that if you are going in a train in this direction, there is another train is coming in the opposite direction, you feel that this train is moving very faster because you will feel with the along with your velocity also. Okay, that's why the relative velocity is like this. Okay, so if the bodies are moving in the same direction, relative velocity is this. If the bodies are moving in the opposite direction, the relative velocity is addition. Okay, this is about the basics of relative velocity. Now we will go quickly about the type problems. Okay, first we will see about the type 1 problem. Okay, so before going to the problem, we will see about what is type 1. I am going to discuss about the type 1 case. That means please look at like this. There is a car 1. This velocity of the car is v1. The position, this is the origin. The position is x1 of 0 and t is equal to 0. Okay, the same time another car. Okay, that is 2 car with a velocity v2. Okay, clear? This position is x2 of 0 and t is equal to 0. Okay, After t time, what about the distance between them? Initially the distance between them is this. What about this distance? That is x2 of 0 minus x1 of 0. Okay. So now what I need to know? Distance between 1 and 2 after t time. Okay. So that is x2 of t minus x1 of t, that is equal to x1 of, x2 of 0 minus x1 of 0 plus, what will take? v2 minus v1 into t. What is this? This is the relative velocity of the second body with respect to first. Okay. By using this equation, you can find out the distance between the two body after t time. Okay. So this is the initial distance plus the relative velocity into t. Okay. If these two bodies are moving in the opposite direction, that means you look at it like this. V2. Okay. Now what about the distance between them? That is x2 of t minus x1 of t. Okay. Is equal to x2 of 0 minus x1 of 0 minus of v2 plus v1 into t. Why it is to be like this? Because it is going in the opposite direction. The relative velocity become addition of that. Addition of two velocity. Okay. So this is the type 1. Based on this, we'll do the problems. Okay. Like this problem you can expect in the NEET and JEE exam. Okay. So what about the problem? A bus moving with a speed of 10 meter per second on a straight road. A car driver wishes to overtake the bus in 100 seconds. If the bus is at a distance of 1 kilometer from the car, what speed car should chase the bus? Okay. So this is the question. We can draw the diagram. I think it will be helpful for you to understand. So there is a bus is there. Okay. Okay. Please consider it as a bus. Clear? Okay. Then a car. This is the car. Okay. This bus is moving with the speed of how much? The velocity of the bus is 10 meter per second. Okay. There is a car is moving with the velocity of this. Easy. What? Initially, the distance between the bus and car is how much? That is 1 kilometer. Clear? 1 kilometer. This car driver, he want to overtake the bus within 100 seconds. Then what is the velocity of the? What is the velocity of the car? Okay, clear? So initial distance between the car and bus is 1 kilometer. That is previously we already got. That is velocity of the bus. Position of the bus initial minus the position of the car is how much? 1 kilometer. That means 100 meter. Okay, clear? Then what about the position after t time? That is the t time is 100 seconds. Okay, so the position of the distance between these two cars. I am consider after 100 seconds, this car is completely chased this bus. So the distance between them is 0. So now you can write that position of the bus t time minus position of the car after t time is equal to the position of the bus minus position of the car. Again, what will get? Plus velocity of the bus minus velocity of the car into t. Okay. So in the t time, this car chased this bus. So the displacement is 0. What about the initial distance between them? That is 1000 meter plus the relative velocity of the bus. What about the relative velocity of the bus? That is 10 minus velocity of the car into the time is 100. Okay. So from this, what you get, you take it this to this side. So 1000 meter, that is minus is equal to what you get, 10 minus Vc into 100. This 100 will becomes to this side. So 100 is comes to this side. So minus 10 is equal to what you get, 10 minus Vc. Okay, clear? This will go to this side, this one will. So Vc equal to how much? 10 plus 10, that is Vc is equal to 20 meter per second. So this car has to move with a velocity of 20 meter per second along the same direction. Then this car can chase this bus. This is about one problem. We will discuss one more problem. Okay. Now we will see type 1 another problem. Problem number 2. Two train 120 meter and 80 meter length are running opposite direction with a velocities 42 km per hour and 30 km per hour. In what time they will cross? Initially, two trains are at 60 meter apart. Okay, this is the question. So we'll draw a diagram. This is the first train and this is another train. What is the length of the one train? That is 120 meter. Another train is how much? 80 meter. Okay, clear? The first train is moving with a velocity 42 km per hour. This train is moving with a velocity 30 km per hour. Okay, and initial distance between them is 60 meter. Okay, this is the question. What we need to find out, in what time they will cross each other. Okay, clear? So the initial distance between the train, that means this is at what? At t is equal to 0. This is the scenario. At t is equal to t, I am assuming that these two train cross each other. That means you will get like this. This is the train, one train, and the second train is like this. Okay, this we will consider the engine. This is the engine of this. Okay, so now you see this is the engine of this and this is the engine of this. Okay, just they will be cross with each other. This is the thing happen after t time. Okay, so now what is the initial distance between the train? That is this train length plus this distance plus this train length. Okay, so now we can use a formula, that is the distance between the train after t time. That is, this I am taken as the first train, this I am taken as the second train. So I am taken like this. So x2 of t minus x1 of t, that is the position of the second train, minus position of this position of the first train, that is equal to x2 of 0 minus x1 of 0 minus v2 plus v1 into t. Why it is to be minus here? Because these two are moving in the opposite direction. What about the initial distance between them? That is 120 plus 80, 200. 200 plus 60, that is 260 minus. What about the velocities? V2 is how much? V2 is to be 30 plus 42, but they are given in the kilometer per hour, so I can convert. So 5 by 18 into time. Time we need to find it. After t time, the distance between them is now 0. So here what you will get, 260 minus 72 into 5 by 18. 5 by 18 into t. The 72 and 18 you can cancel. You are here, you will get 4. Okay, 4 you will get 4 into 5, 20. So 260 minus 20 equal to 0. So 20t is equal to 260. So from this, what about t? T is equal to 260 divided by 20. 0, 0 cancel, and 26 divided by 2. So t is equal to 13 seconds. After 13 seconds, these two trains will cross each other. Okay, this is about the problem 2.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.